Hello, and welcome. This video will cover an introduction to cloud computing. What does cloud computing mean to you? Take a moment, think what cloud computing means to you, and write a short sentence. Cloud computing is the on-demand delivery of compute power, database, storage, applications, and other IT resources via the internet with pay-as-you-go pricing. These resources run on server computers that are located in large data centers in different locations around the world. When you use a cloud service provider like AWS, you are using the computers owned by that service provider. These resources can be used together like building blocks to manufacture solutions that will help you meet your business goals and satisfy technology requirements. Cloud computing enables you to stop thinking of your infrastructure as hardware. Instead, think of it as software. But what does that mean? In the traditional compute model, infrastructure is thought of as hardware. Hardware solutions are physical, which means they require space, staff to maintain it, physical security, planning, and a capital expense. In addition to significant upfront investments, another prohibitive aspect of traditional computing is the long hardware procurement cycle that involves acquiring, provisioning, and maintaining on-premises infrastructure. With a hardware solution, you must ask if there's enough resource capacity or sufficient storage to meet your needs, and you provision capacity guessing theoretical maximum peaks. If you don't meet your projected maximum peak, then you pay for expensive resources that stay idle and don't render you any benefit. If you exceed your projected maximum peak, then you don't have sufficient capacity to meet your needs, and your customers do not receive the service that they desire. If your needs change, then you will spend the time, effort, and money required to implement a new solution. For example, if you wanted to provision a new website, you will have to go out and buy the hardware, rack, and stack it, put it in a data center, then manage it, or have someone else manage it. This approach is very expensive and time-consuming. By contrast, cloud computing enables you to think of your infrastructure as software. Software solutions are flexible. That means that you can select cloud services that best match your needs, provision them, and terminate their use based on your demand. You also pay only for what you use when you use it. You can scale resources up and down in an automated fashion as a way to expand and contract your deployment in order to meet your customer demand. With the cloud computing model, you can treat resources as temporary and disposable. The flexibility that cloud computing offers allows businesses to implement new solutions quickly with very low upfront cost. Compared to hardware solutions, software solutions can change much more quickly, easily, and cost-effectively. Cloud computing helps developers and IT departments avoid undifferentiated heavy lifting work like procurement, maintenance, and capacity planning. They also enable you to focus on what matters most, which is your business and its improvement and evolution. As cloud computing has grown in popularity, several different service models and deployment strategies have emerged. This will help you meet your specific needs for different users. Each type of cloud service model and deployment strategy provides you with a different level of control, a different level of flexibility, and management. Understanding these differences between these cloud service models and deployment strategies can help you decide what set of services is right for your needs. There are three main cloud service models: infrastructure as a service, platform as a service, and software as a service. Each model represents a different part of the cloud computing stack and gives you a different level of control over your IT resources. First, infrastructure as a service are the basic building blocks for your cloud information technology and typically provide you with access to networking features, computers, whether it's virtual or dedicated, and provide storage space. Infrastructure as a service provides you with the highest level of flexibility and control over your IT resources. It is most similar to your existing implementation that many IT departments and developers are familiar with today. Platform as a service removes the need for you to manage the underlying infrastructure. Usually this relates to the hardware and operating system. It does it through automation and allows you to focus on the deployment and management of your applications as opposed to the provisioning. Software as a service provides you with a complete product that is run and managed by the service provider. In most cases, software as a service refers to end user applications. With software as a service, you do not have to think about how the service is maintained or how the underlying infrastructure is managed. You only need to think about how you will use that particular piece of software. A common example of software as a service is a web-based email application where you can send and receive email without having to manage the server, the email product, or maintaining the operating system in that email system. There are three main cloud computing deployment models. Each of these represent the cloud environment that your applications can be deployed in. A cloud-based application is fully deployed in the cloud in the all-in-the-cloud type of implementation. All parts of your application will be running in the cloud. Applications in the cloud have either been created in the cloud or have been migrated from an existing infrastructure. To take advantages of the benefits of cloud computing, your applications then can be built on low-level infrastructure pieces, or you can use higher-level services that provide abstraction from the management, architecting, and scaling requirements of your core infrastructure. In a hybrid implementation, the deployment is such a way that to connect your existing infrastructure and applications to a cloud-based resources. They're not located in the cloud, they're located in your physical facilities. The most common of this hybrid deployment is between cloud and existing on-premises. This extends and grows your implementation while connecting cloud resources to your internal systems. Finally, on-premises. Deploying resources on-premises use virtualization and resource management tools, sometimes called private cloud. While on-premises deployment does not provide many of the benefits of cloud computing, it is sometimes sought for its ability to provide dedicated resources. In most cases, the deployment model is the same as a legacy information technology infrastructure, while using application management and virtualization technologies to try and increase resource utilization. There are many similarities between AWS and a traditional IT implementation. First, AWS security groups and network access control list are similar to firewalls. AWS identity and access management is similar to user provisioning and access control list. Elastic load balancing and Amazon Virtual Private Cloud represent your cloud networking infrastructure, which compares to routers, network pipelines, and switches. Amazon machine images are used to initialize Amazon EC2 instances. They're similar to your on-premise virtual servers. Amazon Elastic Block Store represents a hard disk that attaches to your virtual machines and is equivalent to a direct attached storage. Amazon Elastic File System also attaches to your virtual machines, but it represents a traditional storage area network. Amazon Simple Storage Service, or S3, provides the ability for you to store files using the internet and is similar to network attached storage. Finally, Amazon Relational Database Service is the equivalent to your physical relational database management system. So pretty much everything you will want to do with a traditional data center is available with AWS. Thanks for watching. We'll see you in the next video where you will learn about the advantages of cloud computing. Hello and welcome. This video will cover the advantages of cloud computing. Why are so many companies interested in moving to the cloud? This section presents 6 advantages of cloud computing. Advantage number 1, trade capital expense for variable expense. Capital expenses, or CapEx, are funds that a company uses to acquire, upgrade, and maintain physical assets, such as property, industrial buildings, or equipment. You must pay for everything in the data center, whether you use it or not. By contrast, a variable cost is a cost that you can easily alter or avoid by using cloud computing. Instead of investing heavily in data centers and servers before you know how you will use them, you can pay only when you consume resources and pay only for the amount that you consume. Thus, you save money on technology. It also enables you to adapt to new applications with as much space as you need in minutes, instead of weeks or days. Maintenance is reduced, so you can focus more on your needs and the needs of your business. Advantage number 2, benefit from massive economies of scale. By using cloud computing, you can achieve a lower variable cost than you can get on your very own. Because usage from hundreds of thousands of customers is added up in the cloud, providers such as AWS can achieve higher economies of scale. That translates into lower pay-as-you-go prices to you. Advantage number 3, stop guessing capacity. Eliminating guessing about your infrastructure capacity needs. When you make decisions about capacity before you deploy an application, you often either have expensive idle resources or deal with limited capacity. With cloud computing, these problems go away. You can access as much or as little as you need and scale up and down as required with only a few minutes' notice. Advantage number 4, increase speed and agility. In a cloud computing environment, new information technology resources are only a click away, which means that you reduce the time it takes to make those resources available to your developers from weeks to just minutes. The result is a dramatic increase in agility for the organization because the cost and time that it takes to experiment and develop are significantly lower. Advantage number 5, stop spending money on running and maintaining data centers. Focus on projects that differentiate your business instead of focusing on the infrastructure. Cloud computing enables you to focus on your own customers instead of the manual racking, stacking, and powering of servers. Advantage number 6, go global in minutes. You can deploy your application in multiple AWS regions around the world with just a few clicks. As a result, you can provide lower latency and a better experience for your customers, simply and at a minimal cost. Thanks for watching. We'll see you in the next video. Hello and welcome. This video will cover Amazon Web Services. What is a web service? A web service is an application that is provisioned using the internet. We only concern ourselves with what type of data set we provision to this service in order to do its job, and then we worry about what data set the service gives us back as a response. The implementation details pretty much fall into an I don't care space. We no longer have to be concerned about the language or the platform in which the application is provisioned. So in general, a web service is a piece of software that makes itself available over the internet, or you can actually have it on your private network. A web service normally uses a standardized format for the input data set as well as the output data set. This format can be in extensible markup language, XML, or JavaScript object notation, JSON. This is the data set and the format that is used for the request and the response in order to interact with that web service through an application programming interface. It is not tied to the operating system. It is not tied to the language that was used to develop the software. It is self-describing using an interface definition file, and more importantly, it is discoverable. Amazon Web Services is a secure platform that offers a broad set and ecosystem of web services. These products are basically delivered over the internet, and you have on-demand access to the compute, storage, network, database, or other IT resources that you might need for your projects and the tools to manage them. You can immediately provision and launch AWS resources in just a matter of minutes. The resources are ready for you to use very quickly. AWS offers flexibility Your AWS environment can be reconfigured, updated on demand, scaled up and down automatically to meet usage patterns, and optimize spending. You can also shut them down temporarily or even permanently. The billing for AWS services becomes an operational expense instead of a capital expense. That means that you pay for what you use when you use it. AWS services are designed to work together to support virtually any type of application or workload. Think of these services as building blocks that you daisy chain and interconnect them in order to assemble quickly to build sophisticated and scalable solutions. And you can then adjust them as your needs change. AWS services fall under different categories, and each category contains one or more services. You can select the service that you want from these categories to build your solutions. Which service you choose to use will depend on the business goals and technology requirements of your application. Here are some compute options that you might choose to meet your needs. Use Amazon EC2 when you want complete control over your AWS compute resources and infrastructure. We will use AWS Lambda when you run code and not manage or provision servers. AWS Elastic Beanstalk allows you to provision a service that then deploys, manages, and scales your web applications automatically for you. Amazon Lightsail is actually a cloud platform for a simple web application. You will use it when you just want to launch a web application in a straightforward way. AWS Batch, you will use it when you run hundreds of thousands of batch workloads and you need to run them reliably. AWS Outpost, you will use when you want to run AWS infrastructure in your on-premises data center. If you want to implement a containers or a microservices architecture, you can use Amazon Elastic Container Service, Amazon Elastic Kubernetes Service, or AWS Fargate. We use VMware Cloud on AWS when you have an on-premise server virtualization platform that you want to migrate to AWS. There are also a variety of services for you to choose from in other categories, and the number of offerings keeps growing. The array of AWS services can be intimidating as you start your journey into the cloud. This fundamental course focuses on some of the more The categories that we will cover are compute, storage, database, networking, content delivery, security, identity, compliance, management and governance, and finally, cost management. You might wonder how to access the broad array of services that are offered by AWS. There are three major ways to access and create the ecosystem. The first one, the AWS Management Console. The console provides you a rich graphical user interface using a web browser to the majority of the services and features of those services. The AWS command line is a way of scripting your interaction with the ecosystem. The AWS CLI provides a suite of utilities that can be launched from a command script using a Linux operating environment, Mac OS, or even Microsoft Windows. If you're a developer, you can use a software development kit in order to interact with the AWS ecosystem. AWS provides packages that enable accessing AWS in a variety of popular programming languages like Java, C#, Python, Node.js, and others. This will make it easy for you as a developer to use the AWS in your existing applications. It also enables you to create applications that deploy and monitor complex systems entirely through code. All three options are built using a REST-like application programming interface. This serves as the foundation for AWS. Thanks for watching. We'll see you in the next video. Hello and welcome. This video will cover moving to the AWS cloud using the Cloud Adoption Framework. Cloud computing offers many advantages over the traditional model. However, for most organizations, cloud adoption does not happen instantly. Technology is one thing, but an organization also consists of people and processes. And these three elements must all be in alignment for successful cloud adoption. Cloud computing introduces a significant shift in how technology is obtained, used, and managed. It also shifts how organizations budget and pay for technology services. Cloud adoption requires that fundamental changes are discussed and considered across an entire organization. It also requires that stakeholders across all of the organization's units, both within and outside information technology, support all these new changes. In this video, you will learn about the AWS Cloud Adoption Framework. This is a document created to help organizations design and travel an accelerated path to successful cloud adoption. Each organization's cloud adoption journey is unique. However, in order for any organization to successfully migrate its IT portfolio to the cloud, three elements, that is, people, process, and technology, must be in alignment. Business and technology leaders in an organization must understand the organization's current state, target state, and the transition that is needed to achieve the target state so that they can set goals and create processes for the staff. The AWS Cloud Adoption Framework provides guidance and best practices to help organizations identify gaps in skills and processes. It also helps organizations build a comprehensive approach to cloud computing, both across the organization and throughout the IT lifecycle. This will accelerate successful cloud adoption. At the highest level, the AWS Cloud Adoption Framework organizes guidance into 6 areas of focus called perspectives. Perspectives can cut across people, processes, and technology. Each perspective consists of a set of capabilities which covers different responsibilities that are owned or managed by cross-functional teams. Capabilities within each perspective are used to identify which areas of an organization require attention. By identifying gaps, prescriptive work streams can be created that support a successful cloud journey. In general, the business, people, and governance perspective focus on business capabilities, while the platform, security, and operations perspective focus on technical capabilities. Stakeholders from the business perspective, that includes business managers, finance managers, budget owners, and strategy stakeholders, can use the AWS Cloud Adoption Framework to create a strong business case for cloud adoption and prioritize cloud adoption initiatives. Stakeholders should ensure that an organization's business strategies and goals align with its IT strategies and goals. Members within the people perspective, like human resources, staffing, and people managers, can use the AWS Cloud Adoption Framework to evaluate the organization's structures and roles, new skills and process requirements, and identify gaps in them. Performing an analysis of needs and gaps can help prioritize training, staffing, and organizational changes to build an agile organization. Stakeholders from the governance perspective, for example, the chief information officer or program managers, enterprise architects, business analysts, and portfolio managers, can actually use the AWS Cloud Adoption Framework to focus on the skills and processes that are needed to align IT strategy and goals with the business strategy and goals. This helps the organization focus on maximizing the business value of its IT investment and minimize the business risks. Stakeholders from the platform perspective, for example, the chief technology officer, IT managers, and solutions architect, use a variety of architectural dimensions and models to understand and communicate the nature of IT systems and their relationships. They must be able to describe the architecture of the target state environment in detail. The AWS Cloud Adoption Framework includes principles and patterns for implementing new solutions on the cloud, or migrating on-premises workloads to the cloud. Within the security perspective, members such as the Chief Information Security Officer, the IT security managers, and IT security analysts must ensure that the organization meets security objectives for visibility, auditability, control, and agility. Security perspective stakeholders can use the AWS Cloud Adoption Framework to structure the selection and implementation of security controls that meet the organization's needs. The operations team members include IT operations manager and IT support managers to define how day-to-day, quarter-to-quarter, and year-to-year businesses are conducted. Stakeholders from the operations perspective align and support the operations of the business. The AWS Cloud Adoption Framework helps these stakeholders define current operating procedures. It also helps them identify the process changes and training that are needed to implement a successful cloud adoption. Thanks for watching. We'll see you in the next video. Hello and welcome. It's now time to review the module and wrap up with a discussion of a practice certification exam question. In summary, in this module, you learn how to define different types of cloud computing models, describe 6 advantages of cloud computing, recognize the main AWS service categories and core services, and finally, we review the AWS Cloud Adoption Framework and its use. Let's look at a sample certification question. Why is AWS more economical than traditional data centers for applications with variable compute workloads? The keywords to recognize are AWS more economical than traditional data centers, which indicates one of the 6 computing benefits, and variable, which indicates the need for flexibility. The correct answer is C, the ability to launch instances on demand when needed. Customers can launch and terminate instances in response to a variable workload. This practice is more economical than purchasing enough on-premises servers to handle the peak load. Thanks for watching.